Let's talk about graphing with shifts and reflections, and we'll start with the basic graph of absolute value of x. Okay, absolute value of x. And this is a graph that is best set to memory. This graph is a perfect V with the legs of the V being these perfect diagonals that go up from 0. So something like this. That's the kind of graph you pull from memory, right? We didn't want to have to plot points to get this graph. But my question is, what if we now wanted to plot something like this? F of x equals absolute value of x plus 2. Or maybe f of x equals absolute value of x plus 2, all inside the absolute value. Or what if we wanted to do f of x equals negative absolute value of x? Okay, so we call these top two are shifts, and this bottom one is a reflection. So let's just take a look at what would happen with absolute value of x plus 2. So every x value that went in here, when we put in, say, for instance, 0, let's just see what happens with 0. F of 0, right, we put in 0 for x, it gets bumped up by 2. Okay, and you can see how that would happen with every single value that we put in for x is going to get bumped up by 2 for the y. So what does that do? This shifts our graph up by 2. Shifts up 2 units. Here we go. It's the same graph, just everything is shifted up 2 units. Okay, there we go. So this blue one is f of x equals absolute value of x plus 2. Okay, that keeps going. All right, let's see what happens when we do absolute value of x plus 2, where x plus 2 is inside the absolute value. This one's a little harder. Your intuition may tell you, well, it's a plus 2, so it goes 2 to the right, but it doesn't. It actually goes 2 to the left. And I'll prove it by plotting points, although this is not how we want to be doing things for this section, but just to show how this one shifts it 2 to the left. Let's plot some points. So x, and then we'll let y be absolute value of x plus 2. Okay, the standard points that we choose, maybe something like this: -3, -2, -1, 0, 1, 2, 3. Okay, so let's look at -3. Absolute value of -3 plus 2 is absolute value of -1, which is 1. Absolute value of -2 plus 2 is absolute value of 0, which is 0. And so on. Let's graph these in red. So we have -3, 1. We have -2, 0. We have -1, 1. 0, 2. 1, 3. 2, 4. And 3, 5. Okay, so look what's happened here. We have taken this black graph and shifted it 2 to the left for the red graph here. There we go. So this one here is f of x equals absolute value of x plus 2. Okay, so a plus inside the absolute value shifts left 2 units. Okay, interesting. Now let's look at the negative absolute value of x. Well, what that's going to do is take every y value in our regular graph, this black one here, we should probably just label that, I guess. This black one is f of x equals absolute value of x. And it's going to make it negative. And if it's negative, it's going to make that positive. What that does is it takes all of our nice positive y values and makes them negative. It has the effect of flipping this graph down like so. Okay, we call this a reflection. So this here is f of x equals negative absolute value of x. Let me say this reflects. About what? Well, about the x-axis. We won't talk about it here, but you can also reflect about the y-axis by putting the negative inside. In general, for any function f of x, adding k units on the outside, and we'll assume k is positive here, doing plus k shifts it up and a minus k shifts it down. If you're looking at inside the function, like inside the absolute value, like we just did, adding k shifts it to the left and subtracting k shifts it to the right. So it's kind of the opposite when the variable is on the inside of the function. Okay, and then a negative out in front of the function reflects that graph vertically about the x-axis. So the approach you want to take is to essentially memorize the base graphs, and we'll keep adding base graphs to the library, right, all the way through logarithms, exponentials, trigonometry, and so on. You just keep adding more and more, and then you also really get these shifts down and what they mean so that you can take any base graph and then shift it and reflect it to get a new graph. That's the approach that we'll use.